In spot 3, we observed diode porphyry. We also saw the formation of evidence. This is location and elevation of spot 3. This is a picture of diode porphyry in spot 3. We can tell it is the example of the rock in spot 3. And we can see this content of plagioclase, hornblende, and ferromagnesium minerals. And we saw the texture of the rock is porphyritic texture, and its composition is ferromagnesium mineral and metric, hornblende, and plagioclase as the phenocryst. And this rock relatively younger, it's 80 million years old, and it is the giant intrusion. In metamorphism, we saw the feldspar that have converted to evident at glaciers, and this is an example of regional metamorphism.
In spot 4, we could see the amphibolite. You can see in this picture there is the sign of the high pressure during the metamorphism, and in this picture you can see some garnet in the amphibolite. So this is a garnetiferous amphibolite. You can see the location and elevation of our spot, and this is a non-foliated texture, and we can see some quartz vein as a secondary feature in the amphibolite. In this mineral composition, we found amphibolite, plagioclase, and some garnet in some rocks. You see, this is the largest quartz vein in the amphibolite. This is towards the southeast. And we can also find some other quartz vein. They are smaller than that, and they are to the different directions, which signifies that that amphibolite is tending in different directions. Okay, you can see this is the amphibolite, and this is the quartz which is we collected from the quartz vein of the amphibolite. It's 3.3 billion years old, and firstly it was a basalt, then after regional metamorphism it became amphibolite, and then it uplifted. So it is evidence that there is active volcanism there in the ocean basin at 3.3 billion years ago. The metamorphism shows complete change in composition of the rock, medium grade of metamorphism, and this metamorphism occurs in the very deep in the crust, so we can see the folded like this. We can see at the first, and in metamorphism this basalt converted to the amphibolite. Okay.
Then we move on to spot 5, and this is something very special, garnet biotite schist. Garnet, as we know, is a semi-precious mineral. There we can see 3 spots of garnet. Okay, this is the latitude and longitude and elevation to where we went to. This was the highest spot, actually. And after that, we went around collecting pieces of garnet, which you can see in the sample, pretty big here. And during rock identification, we found out that the texture shown was schistose, and we also saw some granular texture. The mineral composition is basically biotite, a type of mica, garnet, muscovite, another type of mica, quartz, and plagioclase. The history of this rock dates back to 3 billion years. Pretty old, yes? Thin tectonic formation was seen, that is, the garnet crystals were rotating and growing at the same time as the rock body underwent tectonic activity. And shale underwent kind of a metamorphism and got converted to biotite schist with garnet. The textures and structures can show us that schist shows rotating growth of garnet, and the shale converted to schist, as I said. Metamorphism induced the schistosity, and high-grade metamorphism can be observed. So we can be sure that there was some kind of subduction there. And here we have a few illustrations of the entire area as we analyze them.
So, from the information told by the rocks, we could know that there used to be an ocean basin and made of basalt and some sediments that produced sandstones with cross-beddings. And then there are some subductions that caused the original metamorphism. Yeah, and make the sandstones into quartzite and make the basalt into amphibolite. Yeah. And then there's a dike intrusion, and that caused the contact metamorphism and produce some garnet biotite schist.
Last 5 minutes.
So this slide is illustrating the cross section that we have made by ourselves. We can see the bedding plate as we have made as the lines, and also you can see the dike intrusion as the rectangular block that we have made. And also the most important thing here is actually the roles of geosphere, hydrosphere, and atmosphere. So let's take a look at the three main points. On the first point about geosphere, the geosphere is actually involved with something like metamorphism, for example, the quartzite that we see in spot 1. And also we also see volcanic activities or tectonic activities, and also some fracture being made by pressurized from tectonic activities. Moving on to the next point about the idea of, about hydrosphere. Hydrosphere is actually the part of, like, for example, seas or river that actually allows sedimentation, that allows liquefaction of rock, and also it allows erosion and weathering of rock. And next, about the atmosphere, it is this part is actually contributed. For example, like oxygen reacts with some ferromagnesian minerals, creating some brownish colors in the rock that we have seen. And we have an example of the geosphere here. We have an example that illustrates the tectonic activities in geosphere, as shown in the fifth spot about the garnet and syntectonic that my teammate have already talked.
So rocks are not just rocks, they tell us the past history of our Earth. Every rock has a role to play and a different story to tell. That's why it is called the present is key to the past. Thank you for paying attention.
In the crystalline structure and rock type, do you think would occur?
Okay, so if the area was resubducted, then maybe we could observe a kind of a loss of the cross-bedding and the kind of older textures that have still existed in the rock. If there was enough temperature and pressure, we could observe a loss of those older textures, and maybe the schistosity could increase, and certain parts of the rock could get converted into like newer minerals, like change in composition of minerals, or maybe get recrystallized.
If you study, how can you know the temperature and pressure of the metamorphic rocks?
Tell the temperature and the pressure of this rock by looking at the grade of metamorphism. For example, at spot 4 we see amphibolite. It indicates that this spot is actually medium grade metamorphism, like medium temperature and medium pressure. But at spot 5 we see sillimanite, which indicates that there is a high temperature and also high pressure. Thank you.
Like we observed in spot 3, especially the diorite porphyry, let me remind you that the matrix consisted of ferromagnesian minerals, and now iron is definitely ferromagnetic, and there we can observe how the magnetic field of the earth changed through the years.
please can any of you just pick up the schist specimen here?
And as I said, the shape converted into schist by there was a huge subduction, so high temperature and pressure induced schistosity in this rock. And now we can see biotite over here and garnet over here. Now if we see, the garnet is not kind of disturbing the schistosity, it's kind of growing with it. So we can say that the garnet rotated and grew with the schistosity, and therefore it is a syntectonic growth. Kind of it indicates that there was a lot of temperature and pressure acting on the rocks, so the minerals underwent a change of texture and developed the schistosity that we can see over there.
Also, we see the minerals, for example, sillimanite, which indicate high temperature and pressure. If it is not that high, it will create like andalusite or kyanite instead of sillimanite.
Okay, one last question.
We have a last question.
Hello.
Okay, go ahead.
I'm very pleased to hear that your team have visited the summit of this hill. There are a few special features on the top of that hill. What are they?
Okay, at the top of the hill, we actually observed a lot of, it was very windy, and we observed that the atmosphere played a role in creating the landscape. Here we can see an outcrop, and we're actually sitting here on top of the, right on top of the hill, and this particular outcrop, if you see, is made up of the cross-bedded quartzite, and as you can see in the sample, there is this kind of polishing that has taken place. So that's mainly because of the erosion due to the atmosphere. Forces of atmosphere have caused a lot of erosion over there, and so we get a very polished kind of rock exposed there. And it being very hard, as we probably understood when we were getting the samples, the rock has not been completely eroded away, and yet has maintained its identity being the top of the mountain.
Did you see any geologic features like folding and forced weight?
No, we did not observe any folding right at the top.
Yeah, okay. If next time you go there, there is a very nice folding at the summit, and also you can see the plunking direction toward the ridge of the hill, and also you can see a lot of forced vein was along the crest of the pole. Right? Thank you.
Thank you.
And you were finding cross-bedding, right? But is there any possibility that cross-bedding was developed, not under the water, but a sand dune, So if it is a sand dune, how can you, refute that? What is the evidence that it is not developed in the sand dune?
Okay, when we saw the quartzite over there was an alternation of cross-bedding and horizontal bedding. So that kind of indicates that there was a period of turbulence and then a period of quiescence. So that is usually when we have a dry period and a wet period. And so since we already said it was an ocean basin, then we can actually, only using the argument that it was an ocean basin, we can support this fact that there was an alternation of cross-bedding and horizontal bedding.
Hill, which is just outside of Mysore, and as we climbed up, we studied the 4 spheres. And what our goal was to discover ways for them to improve their environment. So we looked at the geosphere, the hydrosphere, the atmosphere, and the biosphere. So for the geosphere, we looked at the various types of rocks. For the hydrosphere, we looked at a man-made lake. For the atmosphere, we looked at how climate changed as we went higher. And for the biosphere, we looked at the use of land by humans and the different types of flora. So we went to 8 different stations, and here's a map of the different stations we went to from Google Earth, 1 through 8.
Okay, so coming to spot number 1, these are the GPS data that we collected. The major observation that we did in spot number 1 was to identify the rock type. The rock number 1, we observed that it was pink to red in color, and it was holocrystalline with subhedral crystals, equigranular, and coarse grain. So, structure was compact and massive, and some of the essential minerals that we observed was quartz and feldspar, with orthoclase feldspar imparting the pink color to the granite. So, considering, and we have the accessory minerals. Accessory minerals that we observed was biotite and hornblende, along with some minute green-colored crystals. So we suppose it could be microcline considering the amount of feldspar in the granite. So considering all the observations, we came to the conclusion that it is pink granite.
And then the rock number 2 it's also granite, but different in color. It is grayish. The color is grayish white, with texture also subhedral crystals, holocrystallines, equigranular, and medium to coarse grained. And there is the picture of the hand specimen of it. And the structure is compact and massive, as you can see in the hand specimen. With essential minerals are quartz and feldspar, and the accessory minerals are hornblende and biotite. And that, so you can conclude that it is a plutonic felsic igneous rock, and with the rock type gray granite. And then this is the station number 1, the location, as you can see, and we observed the structure features there. We found that there were joints in pink granite. So the pink granite is joined into the bedrock. The joints are almost parallel with each other, and then we conclude that the joints. The movements is in only one direction because the joints are parallel to each other.
Here is station number 3. This is about gray granite and pink granite. The location is north 12 degrees 17 minutes and 58 seconds, and east is 76 degrees 41 minutes 880 seconds. The elevation is about 2,697 feet above mean sea level. We observed there is a vein intrusions in the country rock. The country rock is like gneiss, and there's it's called pegmatite. This is narrow, and by strontium and rubidium dating, we can know the age of the country rock is about 2,500 million years, and the age of vein intrusion is about 800 million years. You can see the roots into the joints and crack in search of water, breaking the rock apart, making them vulnerable to further weathering. This is station number 4. The location is north 12 degrees 16 minutes 720 seconds. East is 76 degrees 41 minutes 265 seconds. The elevation is about 2,967 feet above mean sea level. We observe there. This is that one is the phenocryst, which mineral is feldspar, and this big crystal make gray granite has a porphyritic texture. We also observe the pink granite. You can see the small line that is faint and the big one is light, and that is minor joints. This is station 5. This is about man-made lake named the Victor. The location is north 12 degrees 16 minutes 429 seconds, east 76 degrees 40 minutes and 432 seconds. The elevation is about 3,238 feet above mean sea level. We observe the lake as the source of water of the lake is systematic drainage pattern channel rainwater to the lake well water gates. And during other times, it is used by people for domestic purpose, anthropogenic effects, excess pollution due to use of water for domestic purpose. And pollution indicated by green color of water. Water enrichment or eutrophication cause algal bloom and decrease oxygen levels. And the other one is abandoned borewells. The abandoned borewells due to excessive human consumption, exceeding rate of groundwater recharge.
Okay, and the following are station number 7, 6, and number 7. We went to the village situated on a hill, and in this site, we try to observe how human beings interfere in the nature ecosystems. We visited and interviewed the Gram Panchayat to get further information. We got to know that they have declared the Chandamudi Hill plastic-free zone to protect its environment. And we also know that they have a good system of waste management for the purpose to prevent the sacred hill from being polluted. And we also asked about the water resources. The rainwater